Hello everyone, myself is Dinesh and my roll number is 536 and my topic is about factory automation systems, evolution and trends. With the development of innovative technologies such as information-based internet-based information communication, systematic software engineering, open source operating system and many more. These techniques are inevitably being integrated into the traditional factory automation systems, which used to primarily depend on manual handling of trained or experienced operators and lack strong capabilities of data assimilation and decision making support. In addition, such factory automation systems are mostly maintained and upgraded by specific system vendors, especially in the hardware aspect. Therefore, they are highly proprietary and cannot be easily upgraded or expanded to meet the ever-changing user requirements. Evolution of factory automation systems. In the past years, before the PC was widely incorporated into factory automation systems, all production falls were checked and dealt with by trained or experienced operators. For example, in natural gas pipeline network monitoring, all operations were handled in a manual or semi-automatic manner, which has some major drawbacks. For instances, the operator has to do the majority of the work. The abnormal conditions cannot be monitored and handled in real time. The remote measurement variables cannot be monitored, and operators may make mistakes in the data storage. Therefore, it is highly necessary to automate the factory productions and to improve the operating efficiency and the reliability of customer operations. In the recent decades, this picture has been dramatically changed due to wide adoption of industrial PC in various plants, unified development environment, and open architecture. In the control and automation arena, due to large number of customers, suppliers, and integrators, the system maintenance and upgrades used to be a nightmare. As a result, there should be standards among the products from the different vendors. Standards ease complexity of implementation, support, and upgrades. Now, most factory automation systems are adopting the standardized approaches to keep pace with the evolving requirements for industrial productions. All these technologies are deeply concerned with the issues on standardization and open architecture. And one of evolution is Linux operating system. Microsoft Windows NTI 2000 operating system has become fairly popular in the fields of plant automation for last years due to its intuitive operations. More recently, there has been a growing interest in employing Linux OS as developmental environment for various industrial automation systems. Linux is a open source Unix-like kernel supporting multitasking, multi-user, and multiprocessor. In the factory automation area, it is highly necessary to access the complete source codes, including user applications and operating system. If there is any fault occurring, such open sources permit the full inspections. Excuse me. In the harsh and strict environments such as industrial measurement and control, they prefer the more friendly and more familiar Windows interfaces. Therefore, the Windows NT by 2000 platforms are widely adopted. Java programming language. Currently, there are numerous developmental environments commercially available for industrial automation. Among them, some rapid application development track programming languages such as Borland Delphi, Visual C++, Visual Basic, LabVIEW, and HPVEE are used in most applications. However, they conflict with the open system requirements in certain aspects. Java is a platform independent programming language. However, there are some issues remaining open. The main disadvantage of Java programming language is its slow execution speed. As for factory automation systems, the responsiveness and real-time behaviors are integral parts of overall system performance. Therefore, in most real-world applications, Java is only used as assistant language mainly used in network-related programming. Object-oriented software engineering is also one of the evolution of the factory automation system. In the past, software development was relying on individual programmers' risks. That is, a program was considered good as long as it could accomplish the missions well, even though it contained accurate codes which are hard to understand and analyze. With the development of software engineering, especially after the occurrence of object orientation, software engineering, code standardization is becoming a trend for programming. The which means object orientation methodology offers the possibility of structuring a set of information and arranging it clearly. Up to now, a variety of object orientation based factory automation systems have been effectively developed by the engineers in the factory automation arena. The successful practical applications prove that it is efficient and effective in software development. And, and another evolution for a factory automation system is web-based information publishing. In the recent decades, the occurrence of network has opened up many new opportunities and is being widely used in nearly every arena. For instance, by integrating online condition monitoring and important functions across the network, such as collecting, processing, and displaying data. General purpose web browsers, such as general purpose web, such as Internet Explorer and Netscape can access the remote LAN or shop information via Vivid GUI, which are traditionally implemented by X Windows and Motive. TCP/IP is a commonly used communication protocol for such applications. Web-based information publishing. In the recent decades, the occurrence of network has opened up many new opportunities and is being widely used in nearly every area. For instance, by integrating online condition monitoring and network together through visual instruments, we can perform important functions across the network, such as collecting, processing, and displaying data. General purpose browsers such as Internet Explorer and Netscape can access the remote plant or shop information via GUI, which were traditionally implemented by X Windows and Mobile. TCP/IP is commonly used communication protocol for such applications. And another example for evolution of factory automation system is virtual instruments based architecture. Previously, various hardware suppliers developed the hardware drivers for the instruments and devices according to their own specification, which resulted in difficulties in system expandability and interoperability. As a result, maintaining and upgrading such a working configuration may involve a considerable effort. This chaos has encouraged the hardware driver in development to be written to open specifications and standards. Meanwhile, the virtual instruments based system architecture is broadly adopted in various industrial applications, and it is now a standard for such systems. And and last example for evolution of factory automation systems is distributed and embedded real systems. The wide use of novel technologies such as system on a chip (SoC), smart micro element electromechanical systems (MEMS) transducers, commercial off-the-shelf COTS components, internet connectivity, and high dependability systems have brought great revolutions to the architecture of traditional real-time systems. For example, inexpensive MEMS-based sensors and actuators have made it fairly feasible to integrate the physical world and information processing systems in various domains. Excuse me. Such distributed and embedded systems are usually tightly coupled to the physical world and implemented in a real-time manner by making use of restricted resources. Other open specification and standard. Except for previously discussed technologies for open systems, there are also many other standardized technologies used in this system. For instance, SQL, structured query language-based database management, is a data processing, which is of particularly importance for factory automation. OPC, OLE for process control, and XML, extensible markup language, make different applications run properly in a system. Microsoft .NET and C# will also open up new opportunities for this field. It is believed that there will be more emerging innovative technologies making factory automation systems more open. And conclusion. Although many achievements have been obtained in some real-world application towards open architecture, most currently developed factory automation systems can only be thought of as semi-open systems. Since there is still great gap between these systems and real open systems, so there is a long way to go. Despite the potential merits of the open systems, some issues are still remaining open, such as reliability and safety. Reliability of such systems should be carefully considered before embarking on a new project. Compared with the more proprietary systems associated with specific firmware and software providers for specific applications, the promising benefits of adopting open architectures can only arrive with the time going by, and there are no quick returns. However, in the long set, open systems are definitely lucrative for enterprise management and development, especially for long life cycle projects. Such benefits will be more evident since these systems can be upgraded to keep up with the ever-changing requirements without much spend. Therefore, open architecture for factory automation system discussed in this presentation is a key step towards profits generation. And that's it. Thank you.